going to focus on the growing intersection between IT and ET. I'm pleased to introduce Clint Wilder, Senior Editor of Clean Edge, as the moderator for this discussion. Clint joined Clean Edge in 2002. Today plays a leading role in the production of the firm's research and publications. Most of you know Clint from his book, The Clean Tech Revolution, which he co-authored with Ron Pernick, now translated into 7 different languages and has helped really spread the word of clean tech as we know. Today, called it one of the few instances where the economic case for clean tech has been successfully argued without the usual pulling of heartstrings, was what USA Today said about it. Clint and his Clean Edge team had the vision to see this enormous potential back when most lumped us into the category of other. Most of you don't know about Clint that he actually spent 17 years in the IT industry. He covered the IT industry with Computer World and InfoWeek magazines. I do want to, in addition to thanking Lorie Wigle and Rick Needham for joining this, and Clint will introduce them, I do want to say on behalf of Rob Bernard from Microsoft, Rob actually has a spine issue that has come up, and his doctor has advised him against all travel. I do want to say Rob is going to be just fine, but he cannot travel today and sends his regrets for not being here on the panel. But it's my pleasure to welcome to the stage Clint Wilder, Lorie Wigle, and Rick Needham. Thank you. It's a tongue twister.
Thanks, Ira, and welcome back, everyone. I think it was interesting that both Ira and Dan Jurgen talked a little bit about Steve Jobs and innovation, and it's a nice segue to set up this panel on IT and ET, or IT and clean tech, with so much confluence between the two worlds. But when you think about innovation, certainly we have 2 companies represented here today that come to top of mind, Google and Intel. So with me is Rick Needham, Director of Energy and Sustainability at Google, and Lorie Wigle, General Manager of Eco-Technology Program Office at Intel. And to me, when I was asked to moderate this panel, it was great because I do have this background with high tech. And I thought about, so what are the confluences, particularly for large companies like these? And I think that the IT meets ET in 3 different kind of general categories for these companies. Certainly in their own operations, huge data centers, huge consumers of energy, and both companies have worked a lot to reduce their footprint and introduce clean technologies, and we'll talk a lot about that. Also in their own products for their customers, helping their customers, in many cases also very large companies, save energy. And they've also been both very active as collaborators and investors in the clean tech industry with clean tech companies and clean tech projects. So we'll get right into it, and Rick, start with you and just kind of an overview of Google's approach to clean energy, which I know has shifted a little bit in the past few months, and from the renewable energy, less cheaper than coal, RE less than C. Talk about that evolution and kind of where you're at now.
Sure. Thanks for the intro, Clint. Our strategy really hasn't shifted very much. What we are intending on doing, what we have been doing over the last decade or so, is really focus on making a better web that's better for the environment. We as a company are a user of energy. It's something that drives our business, not unlike other companies. And from the beginning, we've always wanted to find what are ways to use energy more efficiently, to use more renewable resources, because we do feel like long-term, sustainable energy is important for us as well as other users of energy. So with respect to our strategy of making this better web that's better for the environment, we focus on several things. One is efficiency, that's in our own operations. We focus on using more renewables, and that's both within our data centers as well as within our kind of corporate operations. And that includes electricity and recycled water, repurposed water. And then we also, right now, have made sure that since 2007, we've actually been a carbon neutral company. So we offset all of our remaining activity that we're not able to solve with efficiency and renewables with high quality carbon offsets. So that gets us to a zero impact company, so you can feel fine when you use Google, you're having no impact on the environment. We have done things that are more externally focused as well to help promote the industry and to help get us to what we think is a clean energy future, and we think that that's important. And those have involved things like the products that we've made, have involved investments in large-scale renewable energy projects, and we can talk more about that. And we've also, as a company and through Google Ventures, have made investments in earlier stage companies. But one thing that we really like to do is deploy new technology into our own operations. We're very much attuned to and welcome new technology. We're willing to try things out, see if they work out, and then roll them out in larger scale. But we also recognize that we're just one small company. So when we talk about the things that we do, we like to tell people how it worked out. So if it works out well, they can scale much more beyond Google.
Maybe not that small, though.
Well, okay, not that small. But in the grand scheme of things, yeah, we're actually just one small piece.
Sure. Well, a slightly larger company, Intel. Lorie, you've been at Intel 27 years. And so you've really seen this kind of evolve and played a leading role. Talk about Intel's approach to clean energy and also at the chip level, you're the core product of your company, how you're making that cleaner.
So, excuse me, like Rick, I could probably categorize this into 3 separate areas. The first is in Intel's operations, where we've had a long-standing focus on having minimal impact on the environment and a positive impact on the communities where we operate. Probably the most relevant fact that I can share here is that we have been the #1 purchaser of renewable energy in the U.S. for the last 4 years. And I think for 2011, more than 85% of the electricity we used in the U.S. came from renewable sources. So that's just one thing that we work on from an operational perspective. We've been transparent about our environmental footprint since 1994. Part of our culture is you measure things and then you continuously improve them. And so that is a big focus in our operations. The second area, which is probably the most important in terms of our actual impact on the planet, is what we do in our products. Given our market segment share and the number of processors that we ship and get used every day in your computers, our product energy use footprint is about 10 times more than our operational footprint in any given year. So driving energy efficiency in the processors is really important. We've developed some ways of thinking about what we've accomplished capitalizing on Moore's Law in this space. And we've done some calculations looking at our forecasts, and we think that there will be 2 billion PCs connected to the internet in 2014. And those 2 billion PCs will use half the energy that the first billion used in 2007, and they'll be able to do 17 times as much work. So we're driving that continuous improvement also in the products. And that comes really from Moore's Law, and it also comes from the movement to smaller and smaller form factors that are more energy efficient. The third thing that we've been working on is also how Intel technology can be applied to solve or address global environmental challenges. And one of the places we've been working is in the new energy space and smart grid, renewable energy, and so on. A lot of people don't realize that every utility grade wind turbine uses 10 to 16 microprocessors. So we, of course, want those all to be Intel microprocessors.
So we'll see Intel inside on the wind turbine.
Exactly, yes.
Rick, back to you. Talk a little bit about this investment in clean tech projects, steel in the ground, as it were, and why is Google doing that?
It's a good question, and one we get asked often. We actually even get asked, why are you even in the energy space? You're a search company, and obviously we do many more things than search at this point. And the fact is that, as we said, our company is driven by energy use, and we have customers that want results very quickly. In fact, we have 1 billion users of Google every day. We have 60 hours of video uploaded to YouTube every minute. So this requires a lot of processing power. And so we came to this thinking, well, we need energy. to effectively grow our business. So let's figure out a way to do that that's sustainable. And that's, when I say sustainable, I mean both environmentally and economic sustainability. So we focus a lot on efficiency in our data centers, which are about, use about half as much energy as a typically sized data center. But then we also focused on renewable energy. And when we looked at renewable energy, we went out and looking, okay, let's find ways to source renewable energy for our data centers, for example. And there weren't a lot of economic options. It was difficult. We ended up going down a route of signing power purchase agreements, and we can talk about that. But one thing we realized is there's not a lot of options out there. So what are the things that we can do to help engender more solutions that we might be able to use later on? And one thing that we recognize that we could do is we could make investments in small and early stage companies. We could actually do some of our own internal development. And then we also had the ability through a relatively large balance sheet and tax capacity to do investments in the United States in projects where good projects were not being deployed for lack of capital. And that's what started us thinking about why not invest in the deployment of these technologies. And our first investment that we did, which was back in April of 2010, was a tax equity investment. It was the first PTC deal that had been done in about 18 months, so post the financial crisis, where there used to be 12.5 tax equity providers prior to that, and afterwards there were 2 and effectively 1. Now that's a definition of a constrained market. So there's lots of projects that were good projects that weren't getting built for that lack of capital. So we threw our iron into that fire. We said, sorry about that. We'll be a player in tax equity. We'll be able to provide capital as well. And what we've realized is this is a great opportunity to make a good business investment. We're making good returns on these investments. It helps us to diversify our cash into another type of asset. And at the same time, it's an asset that we really want to help support anyway. So it made a lot of sense for us. And as we've done several other investments, we're now up to, I think, 8 investments and totaling over $915 million. These all have been great investments with respect to the returns that we can see as a company. So this is not corporate philanthropy. And yet they're also helping to deploy, in some cases, transformative technology, new technology. So Bright Source's Ivanpah plant will be the largest solar power tower of its kind. We have an investment in a very transformative cable off the mid-Atlantic coast that will allow 6,000 megawatts of offshore wind to be connected. And it's a, kind of a smart way of doing it through high voltage DC. And we also have investments in large-scale wind projects like Shepherd's Flat up in Oregon, which will be 845 megawatts, the largest wind farm built when it's complete, and that's moving along well. So these are all great deployments of some newer technology. Even Shepherd's Flat's using a turbine that hasn't been deployed widely in the US that has a permanent magnet generator, better efficiency at low wind speeds and greater reliability. So these are things that we're helping to move forward the technology and making good investments and good returns. And we've been quite happy with the investments so far. And we would also encourage other companies to take a look at this. The thing that's quite interesting is with the cash grant allowed other investors to come in that didn't need tax capacity to make these investments. That's now expired. There's a large demand for tax equity that's coming, on the order of $7 billion this year, and there's not enough capacity in the market. And yet, there aren't that many players in tax equity still. We're still, I think, the only non-energy, non-financial company making these investments. And yet there's $137 billion in tax capacity in any given year, just the top 500 companies. So there's the capacity to do this more. And we would encourage other companies to talk to us about it. And we can tell them about what we've done so far and why we think it's been great.
Mm-hmm. Intel is also another big investor in the industry. Lorie, talk about what you have in terms of companies, projects. What's the kind of overall approach?
So, excuse me, first of all, my colleague Steve Eichenlaub is here. Steve can wave his arm. Steve is in Intel Capital, who work, and they work obviously on the equity investments and some of the business development in the clean tech sector. So he's really the point person on investments. I can talk just a little bit about the work that he and his team do kind of in conjunction with my eco-technology efforts, as well as our various product groups. He is a great source for us of new insights and is making strategic investments that align with the things that we're doing internal to the company. One of the areas where we've worked together quite a lot is in data center efficiency, and some of the companies that are innovating there, which is obviously very aligned with Intel's business as we're selling the processors that go into servers. It's also an area where we think there is a huge opportunity for a lot of innovation. As we build out the knowledge economy, we're building more and more data centers. We have wonderful companies like Google that are putting these very large facilities in place, and so it's really important for the industry to drive energy efficiency there, both because we are such large consumers, but also because we want to make sure that we maintain a good, supportive regulatory environment. We would hate to have governments look at data centers as big energy users and emitters and try to stifle the innovation that's occurring in the data centers.
Yeah, let's get into that a little more. So both the technology that you're providing, and Rick, you mentioned your data centers are much more efficient than the standard. How is it done?
So maybe I'll start with kind of what we're doing at a, I guess, user of data center or constructor of data center role. So we've been obsessive about this for about a decade. As I mentioned, energy is a core part of our business. And we've taken a look at everything soup to nuts in a data center. So as Lorie mentioned, there's certainly the critical piece is the server itself, the piece doing the work. You want to be able to make that do as much work as possible for as little energy, and it's been amazing the innovation that's resulted in the current status of technology there. The other part of it is actually the rest of the data center that makes it all work, and typically that's like cooling systems, light, the structure. And data centers today typically spend about as much energy in the server side as they do in just keeping the data center up and running. And there's a metric called PUE, power usage effectiveness, which basically measures the comparison of those two, total energy over the server energy, basically. And those are typically around 2, which isn't great. We've spent a lot of time making sure that the servers that we use are as efficient as they can be and really just give us what we need and don't have things that we don't need. So we've been able to make those, shave probably about 15% or so of the energy off what a typical server would be. And a lot of that comes from evolution in the chips and components that go into that.
And is that working with the vendors, or once you get it, then you play with it?
It's both. So we do make our own servers. We put them together, but a lot of it comes from the architecture of that server, but also the components and the pieces that are in there, obviously. Then there's there's a little bit of a savings there. The big savings that we've seen in operating data centers is on more the structure and the overhead energy involved. A lot of it has to do with cooling. So we've done several things, and we publish all this, and we tell people what we've done in kind of some simple, easy steps. Things like run your data center hotter, right? You can run it hotter. It's okay. But we've talked to the manufacturers about what happens if you run these components at higher temperatures. And they said, well, it's not under warranty. So why not? What would actually happen? And so we work with them to identify how far can you go. Other things like making sure you're managing your airflow so your cooling air doesn't hit the hot air before it even hits the server, and you're wasting cooling air. So very simple things like, you go to a supermarket, you have a meat locker, it's got this little, plastic curtain. We use those in our data centers to carve off airflows. It's very cheap and easy to do. Things like put a blanking slate behind an empty server bay so that the cooling airflow doesn't, basically short circuit the airflow. So we've done a lot of things with respect to improving efficiency on the data center side. And it resulted in, data centers that are probably, again, twice as efficient, use half as much energy as the typical ones today. That saved us well over $1 billion over these past 10 years. So, and we continue to have a lot of savings because of those efforts. We've also done, that's the data center efficiency side, and then on procuring power for data centers, we went around and looked at how do we actually get power for our data centers. And we spent time thinking about what are structures where we can procure power and use that to offset our own data center usage. And we have structures in place that allow us to do that. But one thing that we say is, you can have a data center and you can put some solar panels on top, and that looks wonderful, and you can bring a senator or a governor by and say, isn't this great? But that's just a little bit of energy. Or you can put up wind turbines on your site and say, hey, isn't this great? But the place where you put your data center is usually not the place where you have the best output for a wind turbine or solar panels. So what we've done is we've actually contracted with wind farms that are further away from our data centers, but frankly, if you look at the impact they have within that grid, it's much better to put a wind turbine over there where the capacity factor is 40% versus next to your data center it might be 20%. So we've had contractual arrangements to basically purchase that power and use that to offset our data center usage. So we're very keen on and very attentive on our data center energy usage, and it's through efforts of companies like Intel to make sure we're getting some of the newest components too. One thing we do with our data centers too is swap out equipment as it matures. As a company, we've always been, we like to be able to swap out things and iterate.
Yeah, and as a technology provider, I also want to, when you're talking about it, also talk about what's the business case for making your products more efficient.
Yeah, it is really interesting in the data center example. We did some analysis recently where if a data center has a third of their servers that are 2007 or older, those servers are using 2/3 of the energy that's being consumed by the data center, and they're only producing 4% of the work. So that just gives you one example. I mean, picture those pie charts of why this notion of refreshing the servers is so important. And that happens to be really good for Intel, too, because it's driving this refresh cycle. So it's a kind of an example of the double bottom line. We, of course, encourage people to make sure that they recycle those servers as they take them out of the data center. But that is an example of where it's good economics and good for the environment. The other thing I wanted to add on to what Rick was saying about data center efficiency in particular, that's something that no one company can go do. What needs to happen is we all have to work together as an industry. And I can testify to Google's innovation in that back in the 2006-2007 timeframe, they were looking at ways to make the servers they were deploying in their data centers more energy efficient. And they realized that there was a big area of waste in the power conversion that was happening both in servers and in PCs, in that the power supplies weren't very efficient. At that time, desktop PCs were wasting 50% of the energy that was coming out of the wall because we would lose 30% as it was converted from AC power to DC power, and then we'd lose another 20% on the motherboard. Servers were a little bit better, only 70% efficient. And so we ended up actually, Google really pushed Intel to get the rest of the industry on board, and we founded Climate Savers Computing Initiative to go tackle that. And we've driven both platforms now to above 90% efficiency. And we estimate that we reduce carbon emissions from computing probably on the order of 42 to 46 million tons a year just by doing some simple things like that. So, I mean, kudos and hats off to Google for pushing and goading the rest of us to take that on.
Yeah, tell us.
Lorie's leading the charge there now, too. So.
Yeah, I'm the president of Climate Savers, so I'm kind of I'm proud of it, too.
Yeah, tell us more about that initiative.
Yeah, so Climate Savers Computing Initiative was founded in 2007 with this idea of improving energy efficiency through power delivery and then trying to get people to use power management. If you have a notebook computer and you're running on your battery, you take advantage of the power management, but any device that's plugged in, people just don't take advantage of it or don't let your PC go to sleep. And so we were trying to target both those things. And from an Intel perspective, we've been building power management into our processors since the late 80s. So it just seemed like such a waste to us that people weren't taking advantage of it. So we laid out goals associated with both of these two areas. We were able to enlist most of the PC and server manufacturers to help us with it. And what we did with them, and it was interesting because there wasn't really a lot of new invention that needed to happen. There was just a lot of inertia because the manufacturers didn't believe that anyone would pay a little bit more for something that was energy efficient. So what we tried to do was to break that cycle by asking IT buyers to pledge that they would spend as much as $30 more per system to get an energy efficient model. And we have about 600 companies now that have made that pledge. And that was enough ammunition to get the manufacturers to build at least one model that met our efficiency criteria, and then we were able to accelerate the transformation.
A lot of people, when you talk about the confluence of IT and clean tech, the first thing comes to mind is smart grid. So let's talk about that. And Rick, starting with you, there's been news about Google backing off or discontinuing the power meter. So talk a little bit about how that started and ended, and you know, your overall smart grid approach.
Sure. So smart grid's a loaded term. It covers so many different
Yes.
things, right? And the smart grid ecosystem goes from, you know, transmission through distribution to end-use devices and load control, and then active load control. The power meter effort was an idea to provide people information in real time, near real time, on their actual energy use. So it allowed, basically gave that information to users. It was either through a device that they had installed or through a smart meter through their utility. I think what we saw was that working with utilities in this space can be difficult to roll things out. They had questions about deploying even smart meters, and were they able to make those capital investments? Would they be obsoleted? You know, so there's issues on whether they're even deploying smart meters. But having information shared with the user, the person whose home it is, there are issues on how do you get that information there, and are utilities willing to share that information? And what we saw was there wasn't a huge pickup in the number of people that were signing up for some of these this service. Part of it might be how it's actually was pitched to the people. Part of it might be the partners that we were working with. But what we also realized is, one of the things that we're quite pleased with coming out of that was we had a very strong drumbeat that the information that people have with respect to their energy use should be their information that they're able to do with what they want. It's not information that belongs to the entity that puts a meter on your home, but rather to you. It's your own information. And so the beauty of the power meter system was it was basically would provide an open API that other developers can then use that information, if someone had opted in to share that, where you can develop a number of apps and services that can be related to that information. And that was something, which in the stimulus package with respect to smart grid, there was a component in it that basically made that a requirement that some of the information would be shared with the end user. It couldn't just be kept. So we thought that was actually a really good outcome. As we look at smart grid, we also realized, listen, probably everyone in this room is pretty interested in energy use and their own energy use. Most people don't spend a lot of time thinking about it. And it's a bill that they pay, and I think they interact with their utility bill something like on the order of 3 minutes a month. And if you have automatic pay set up, it's probably not even that. So it's not something that a lot of people spend a lot of attention on. So the question is, what are the places where, if you had a greater information flow on real-time use, where can you find some value for that? And it may not be with the end user. The end user may get, you want to basically disturb the end user as little as possible. Make it almost transparent, and find opportunities where you can provide some of the value. What's the value? The value is greater integration of renewables, preventing you to have to build the next peaker plant. It's greater load control. Some of the ISOs have ramp problems they have to deal with. So it's quite difficult for them as we get into a greater renewables penetration scenario of how to deal with that. And you could do things like, use demand response and other load management techniques to help make the jobs of the utilities and the ISOs a little easier. That's not something that you sitting in your home, or you, not you, Clint, maybe you are actually concerned about that, but most people are like, not that attuned to that. So we're looking, what are ways that we might be able to do something there that makes sense, and the value can be attributed to the right organization.
Mm-hmm. So you're in the process of figuring that out. Where else in the smart grid chain Google wants to play?
We're always interested in, is there some place that makes sense for us to play? We don't have like a smart grid initiative kind of kicked off or anything, but we're always paying attention to issues or pain points that we might be able to solve with the kind of unique things that Google can do.
Mm-hmm. And where does Intel want to play?
Well, you know, we're interesting. I sometimes joke that we're the smart grid company nobody ever thinks of because we actually have products that go into the smart grid pretty much end to end. And kind of like Google and Microsoft, we were really, really interested in home energy management in the early days. We did a prototype home energy management device that our CEO showed it at CES, really flashy. You go and look on YouTube, there's a commercial with me talking about personal energy. So we did do some work there. And we're still very interested in that. I think it's been very gratifying, as Rick says, to watch the evolution of the access to information. We collectively pursued something called the ENO bill, which was kind of the legislated right to have that access to that information. But what's ended up happening is it's come more through funding, and there's currently a funding opportunity that's open until the 1st of March to build on something that the White House CTO initiated called the Green Button, which is utilities offering access to the utility information on their websites. So still work going on there, but also an interest in end-to-end. We've been involved in a project called the Pecan Street Project down in Austin, and that has given us some insight into some of the things Rick was referring to in terms of what we can learn as things are better instrumented. They have, I think, close to 200 homes now that have smart water, gas, and electricity meters. And the data is getting pumped into the Texas Accelerated Computing Center, and they're starting to do some analytics on it. And they're discovering things like the air conditioning systems that they were paying incentives on because they were supposedly better actually aren't. You know, things like how the solar panels are sited, you know, they can optimize now based on the analytics that they're doing in the data center side, which, you know, may end up being the biggest business opportunity for Intel is the build out of the data center capacity to deal with all the analytics and the meter data.
In just a couple minutes, we'll open it up to questions, so be thinking of those. Let's talk about deployment of clean technology, particularly leading edge stuff. You know, nothing wrong with big solar arrays on your rooftop, but what are some of the things that both your companies are doing on campus and at your facilities to you know, push the envelope a little bit in terms of deployment?
Sure. So we're always interested in incorporating newer technology into our operations. On the data center side, there's a whole team that's focused on what are the technologies they can deploy into the design and build of the servers, as well as the data centers themselves. So some of it's newer technologies. For example, Google Ventures is invested in Transform, a company that's looking at power conversion and making that more efficient. But we also look at the data centers kind of writ large. You know, an example is our large data center in Finland, which we just opened up. I guess I have a loose shirt here. Just opened up, and that uses seawater from the Gulf of Finland to come in and cool the data center. So it's not like newer technology. It's actually a 1950s building, an old paper mill that we converted into a data center. Pretty cool site. Within our own kind of corporate operations, though, we're always looking at newer technologies. We were the first commercial site of a Bloom fuel cell, which uses natural gas to provide electricity. That was back in 2008 when we had those installed. We've been looking at potentially new solar technologies that we can deploy on our main campus in Mountain View. We'll also be building out several new buildings in Mountain View. So we have an opportunity now to actually incorporate technologies into the actual build of these buildings, as opposed to just taking over and retrofitting a building. So that's a great opportunity, and I would encourage people, if you have a technology that would be useful in an efficient building build-out, definitely let us know. We're in the midst of looking at what we can do there. But we've actually, in our, for employees too, we also focus on our employee kind of benefits and things that we can do to encourage our employees to be more sustainable. We've actually went out and bought a bunch of EVs. We have the largest kind of EV fleet. I think we have 39 vehicles right now, which includes Leafs, Volts. We actually have some, the newest EVs from Ford and Honda as well. And
any Teslas for Employee of the Month?
We don't yet have Teslas for employees of the month. But maybe if Tesla gives us one of these Model S's, we can make that available. We do. We do have some roadsters that ride around campus, owned by Google employees, but we've actually installed one of the largest corporate EV charging infrastructures as well. We have over 200 chargers right now, and what's been interesting is those are used for our fleet of cars that people can take out and run errands with in the middle of the day, so they can drive around and leave. It's actually a great chance to test drive these EVs while you're doing something. Those vehicles are quite useful because we actually shuttle in a bunch of people every year. We've had probably over 1 million rides that we provided over this last year to people within the Bay Area to our main campus. But the EVs are great, and the charging infrastructure is great because people can go buy their own EV, drive it to Google, plug in, and we pay for their charge while they're at work, and they can drive home. So this actually has enabled some employees who would otherwise not buy an electric vehicle to be able to buy it because of the range they would be concerned about. And even just this fleet of EVs, we've only had for several months now. We've already had over 20,000 kind of rental periods where people can sign up for them, 20,000 rentals, and we've already driven those EVs over 250,000 miles just for our employees and just over the last few months. So it's something that's a great benefit. And those are we're always interested in newer technologies in the transportation space too. We have a new fleet of shuttles that has the newest kind of engines. We're using biodiesel in those engines. We're going to be swapping out other fuels and trying those out as well.
And how about Intel for many thousands of people working there? And also you mentioned in your manufacturing operations.
Yeah, and actually a lot of it is pretty similar in terms of the things that we do from an operational perspective. I was talking with Clint and Rick a little bit earlier this morning. One of the big impacts that we can have on the environment is in our approach to manufacturing itself and making the silicon. Obviously, being the stewards of Moore's Law and continuing the shrink of the manufacturing process requires a lot of innovation. But the other thing that we've been trying to do over time is continue to make it more environmentally friendly. The latest effort that we've undertaken as an industry is eliminating halogenated flame retardants from the manufacturing process. And I think the really nice thing about the semiconductor industry is as we create the technology required to do that, we share it across the industry as opposed to trying to keep it close as a competitive advantage. So that's, I think, been a very positive for us. We've done the same thing with PFC emissions across the industry. I also think the employee engagement piece is really important. And for the last few years, what we've been doing is building into our employee bonus structure an element that's focused on the environment. So that gives employees the opportunity to focus on either if they're design engineers, making the processor more energy efficient, or if they work in a fabrication facility, looking for energy efficiency projects. And then we track that all, and we actually all get paid on it. So that's kind of nice.
Great. Any questions? Yes. Okay. Question has to do with product obsolescence, and how are you working with that?
So I can go first if you like. From an Intel perspective, given that we're an ingredient in the product, we don't have a lot of direct interaction with the customer as they're replacing the equipment. So the way that we approach it is to work with our customers, the equipment manufacturers, and most of the big ones especially have very, very good recycling programs in place. And so, we do whatever we can to support them in that, things like the halogen project certainly helps them with the end-of-life process. For our smaller customers that might not have the resources to go and qualify recyclers to make sure that equipment isn't being shipped to developing countries and that kind of thing, we've actually undertaken the effort to go and do the qualification, and then we provide access to the recyclers for those smaller customers.
I know when we look at replacement of devices in our data centers, we're very focused on the recycling of those, reuse, recycle, And there are some parts of it that you can't, so we're responsibly dispose of those things. But it's actually a very, very small part of those servers. Most of it, the wide majority, can actually be reused or recycled. And we're very attuned to that. Obviously, when you actually swap out a new server for an old is a very, you can make that decision based off of the work that server can do, the energy consumption, all those things. But we're always refreshing our fleet within our data centers, and because we're building out more data centers, we have opportunity to, to take a lot of the things that we might otherwise have gotten rid of and continue to use those. So
Waterfall.
Yeah.
Okay. Anyone else? Yeah.
Thanks very much for everything both of your companies are doing. And clearly, these are companies that are leading the way in a lot of these initiatives. From a practical standpoint for another organization, from a practical standpoint for another organization like my university, what part of the beast do we tap into to both extract some of the information that you've been describing in terms of your best practices, but also share some of the experiences that we may be having that you could then leverage in terms of moving forward? How do we actually engage on this topic?
That's a really, really good question. And I would offer up two organizations that have a very good appetite for the dialogue and for engaging. One is Climate Savers Computing Initiative, which is really focused on individual servers, PCs, and their energy consumption. And we're expanding our focus to comprehend the whole life cycle. So looking at everything from embodied energy through the use phase into end of life. The other is, if you're interested in data centers specifically, there's another organization called the Green Grid. And that organization has just a plethora of best practices. They came up with this power usage effectiveness metric that Rick referred to, and are constantly evolving, really want, again, the engagement with the end user community to inform the technical work that we undertake. Intel's on the board of that also, and in fact, one of my team members runs the technical committee, so we'd love to get you engaged with that.
And we, I guess with respect to engaging on best practices, one thing that we've done is we've put a lot of the information just about what we do with respect to our data centers out there on the web. You can search using your favorite search engine and find it. But it's actually, there's pretty simple step-by-step videos and descriptions of what we're doing, and it can go into some of the details as well. There's some detailed stuff out there, and we track our performance every quarter on the PUE measurement. But what we found is that large data centers, while people malign them somewhat for being large energy users, they're actually a pretty small portion of the total data center usage. There's a lot of smaller colos and other things, where some of these very simple things can be implemented. So I'm talking about here, if your university has servers that you're using, there's some simple things that you can do to actually make those more efficient too. And then there's always the moving to cloud services as well. We actually recently just disclosed our carbon footprint for the first time this past year. We talked about our actual energy usage. And in so doing, we also highlighted the fact that moving to cloud services generally can be quite efficient versus locally hosted email, to cut to the quick. A Gmail user, if you use, people who use Gmail in a cloud versus having their own email hosted, is about 80 times as efficient. So for the energy usage of one locally, one local server, you could basically fit 80 of those into a cloud service with the same kind of environmental impact. But I would say check out what we have there. I'd be happy to engage if there's something that you think would be interesting to talk about with respect to data center design or efficiency or server design. We're always happy to talk to people who are working in the field and see if there's something that we can adopt.
Time for one more. John?
Mobility. It's clearly Intel's inside new things. Google is being used in different ways. How is mobility impacting?
The question is, how is mobile devices impacting your business?
Well, from our perspective, it opens up just a huge amount of opportunity. We really look forward to day when we've got 50 billion things connected, and we're taking advantage of that. I think there's so much opportunity to use mobile devices in particular as sensors and to collect environmental data, information about where people are. We've done some research in that third area that I talked about of opportunity for technology to address global challenges in looking at disasters and how can you use technology to both prepare and recover more quickly. And mobile devices are playing a huge role there. Just one example.
So you probably know mobile is a big part of our business through our Android systems, Android tablets and phones. So it's a real big part of our business. We do view the mobile devices as the way that many people, that's their primary means of connection. And certainly in the developing world, that is like the most used way of connecting to the internet through SMS messages. We actually have even efforts in kind of developing markets and identifying products that we can use through SMS that provide functionality to people, like auctions of things through SMS messages, and are doing some interesting things there. But mobile is clearly a huge growth opportunity and business opportunity. And to Lorie's point, these mobile devices actually they're not only providing you information, they're quite knowledgeable about where you are, what you're doing. And so, we have lots of thoughts about what can Google do with that mobile device. Things like it knows where you are, it knows what you generally like, it can give you options to, it knows it's lunchtime, so why not give you a coupon to this Thai restaurant that you just walked by that we know you like Thai. And these are all things, obviously, that you'd opt into so that you're getting the best user experience. But ideally, you can have a device that knows you quite well and becomes like your personal assistant, and tells you things that you might not have known that you really wanted to know, and then you're kind of delighted, like, wow, that's actually great. But you can use them as sensors for things like, when you have sensors all over the place, you can use it, for example, to monitor traffic patterns, right? You have enough of these devices. It's a real-time traffic measurement device. You don't need helicopters flying overhead to tell you where the traffic is. You know it. And it knows it for you, and it can reroute you, right? So I think it's a big opportunity.
It's always good to end on a future-looking note. Please join me in thanking Lorie Wigle and Rick Needham.